of routers, know how routers select optimal route, understand the concept of routing table, and advanced routing feature. Here's the content. Overview of the IP routing. We start from this one first, the basic concept of routing. First of all, the background. Inter-subnet communication. An IP address define a node on a network, which IP address belong to a unique subnet. Okay, semua IP yang kita configure kan, so you have to make sure it's actually unique and they have no duplicate. Each subnet may belong to a different area of the network. To implement IP addressing, subnet in different area need to communicate with each other. So, kalau kita punya network sini kan ada banyak tree, this is the router. So, all the connections here, they got their own IP addresses. So, for the example, this is LAN, okay, the local area network. So, how to communicate with the network M? So, how the N boleh sampai ke M dekat sini? So, ini akan based on di dalam device punya routing table. So, first, the route. Route are the path information used to guide packet forwarding. The routing device is a network device that forward packet to destination subnet based on the route. The most common routing device is the router. Okay, so kita selalu kan mengapa di WAN punya area kita ada banyak router. Okay, sebabnya di dalam router kan mereka ada itu route table, ia boleh guidekan packet forwarding. So when data is sent to the router will going to look up at the routing table. So it will based on the routing table, right? Check on the route. Kalau saya ada itu route boleh pergi ke M, then I akan tolong. If I don't have the route, go to the destination, then sorry, I have to discard your packet. Okay, the router is actually very straightforward. Okay, if I know, I'll forward. If I don't know, I will discard your packet. And this is the routing information. A route contains the following information. The destination yang dekat sini. Okay, so dia akan pergi check kan, adakah saya tahu macam mana pergi ke itu destination. So what is the subnet mask? Okay, so dia nak tahu mana satu tempat ialah network. So kalau sini gunakan /2/4, so that means di kotak yang atas sini kan, this is the network address. Yang last ini ialah host punya bit. Okay, host punya bit /24. Then outbound interface. Kalau I nak hantarkan paket pergi ke network ini, so mana satu yang saya punya interface boleh hantarkan itu paket. Okay, so yeah, this is the interface. So after I send out my packet, I also need to know which one is my next hop. Okay, because sometimes I know what my outbound interface. I perlu keluar dari port nombor 0, tapi kan itu paket sudah keluar kan, dia tak tahu who is my agent. Okay, who is my agent? So now they have two router. One is .2 and another is .3. So that's why they also need to clarify that. Okay, I should look for the .2. So this is the person. So when I want to find the destination, my packet is Ethernet port, go to look for this agent, this gateway, and this gateway will help for the destination. How the router is actually perform the route. Okay, the next. IP router discover route with using the multiple method. A router select the optimal route and install it in its own routing table. So biasanya router dia boleh gunakan banyak cara untuk belajar itu route, macam mana pergi ke itu destination. Kita boleh enable kan dynamic punya protocol kan, kasih mereka belajar kan itu network. Atau we actually configure manually. Okay, so we can use it in a dynamic way or we do manually to help the router to create the path. Okay, you can select either one of the method. So for this thing, there's called routing table. All right. So this routing table, dia selalu ada few element yang sangat penting. Destination, next hop, dan outbound interface. So sekarang, maybe you already understand what is called the routing table and the route. Macam mana router for kind of packet? Okay, so ini cuma ialah basic saja. Router, they actually will look for the routing table in order to forward the packet. Okay, then the second, generation of routing entry. How to obtain a routing information? A router forward packet based on its own routing table. To implement route-based packet forwarding, the router need to obtain route. First, dia perlu dulu. Kalau tak ada itu route kan, forward to packet. So, okay, yang paling pertama, mereka panggil direct route. Okay, the direct route is mean those connection which is direct connected to me, then I will learn it automatic. So direct route dia bukan static pun bukan dynamic. Okay, ini ialah sebenarnya asal daripada sendiri. That's why dia panggil direct. Okay, so this is one of the example here. They're using the router at the middle here. So this is okay. Because the router here, I got two interface, one on the left, one on the right, one left, one right. So my this interface, G001, my IP is 2110. Okay, so not. Okay, sekarang saya tahu. Okay. Then after that, on the other side, the 10110 is on the gig 000. Oh, okay. Then I begin register. So this one we actually done it automatic and we doesn't need to do anything by default. Sebab ini ya sistem punya recognitions. Kalau you sudah configure itu IP di itu port itu interface, ia automatic tahu apa IP address for itu interface. Okay, dia memang tahu punya because you already configure the IP on the interface. Okay, so this is called direct. Okay, this is called direct. The other one, static route. A static route are manually configured by network administrator. Okay, so ini static route kan masuk ialah the router they will actually based on the route that you actually configure for it. Okay, so kalau you suruh dia gunakan itu outbound interface atau next one kan, dia akan follow. Okay, so this all defined by the network administrator. Like example, they do it on this router di sini. Dia cakap, kalau you nak pergi ke 30.1.1 this network, okay, the outbound interface you should use the gig 001. So mean you have to forward to here in order to go to this destination. And this route is called static. Okay, so this is called static. For the dynamic route are learned by routing protocol run on the router. Okay, that means that sekarang as an engineer, you hanya perlu tahu macam mana pergi enablekan dynamic routing protocol. Then just leave it. Because the dynamic routing protocol will automatic exchange the route. Okay, they will do that route exchange automatic. So they will automatically know that, oh, if I want to go here, the 40.1.1.0, okay, this is my router. Okay, I will know that which is my outbound interface for me to go there. Dia akan automatic faham. You tak perlu pergi cari kan, where is my outbound, where is my next hop, tak perlu. So the direct route. A direct route is automatically generated by a device and point to the local direct connected network. When a router is last hop router, IP packet to be forward will match a direct route, and the route will direct forward the IP packet to the destination. So when the direct route is used for the packet forwarding, the destination IP address of the packet to be forward and the IP address of the router outbound interface are in the same subnet. Okay, so this is what they actually mentioned. Tadi saya explain ya. Router B sini other port 10.0.0.2. So they based on this one, they already know okay 10.0.0.2 kan. This ini sebenarnya lah IP kan, tapi route yang boleh register di dalam routing table kan, dia mesti nak gunakan network address. Okay, faham ah? Network address. So ini IP kan dia akan convert jadi 10.0.0/2. Okay, tak boleh ada host nombor dekat belakang sini. Okay, sebab ia perlu register ke dalam routing table. Okay, network address. That's why you can see it like this. Ini ialah direct. Saya sendirinya. Then itu next apa? Dia akan tunjuk 10.0.02. Ini IP saya sendiri. Sebab ini next hop kan, ialah saya punya interface G000. Tapi dia berada di dalam network 10.0.0. Ini macam kita punya street name kan. So, you punya rumah, you tinggal di satu jalan, Asaba jalan 16. Okay, jalan 16. Okay, but for your house, unit number is different. Maybe your unit number is unit number 10. So unit number 10 akan letak di belakang sini. Ini ya you punya unit number. Tapi, okay, dia cakap, okay, this is your unit number kan. Tapi you punya jalan street name is actually this. This is your street name. 10.0.0.0. Okay, without putting any unit number. Okay, so ini ya beliau masuk lah. Okay, then on the other side, gig 001, then like this, the network address 20.110.24. Yeah, so that's what you can see. This is a destination. Direct, then the next hop, and my outbound interface, dia lekat dekat mana. So this direct route will be actually automatic generated. Okay, you doesn't need to do anything. Not all the direct route generated for the interface are installed in the IP routing table. Only the direct route of which the physical status and the processes of the interface are then will be installed in the routing table. Kalau you sudah configure itu IP address kan, jangan ingat dia akan sentiasa install ke kita punya routing table. Kadang-kadang ia tak install punya. Sebab for router right, it's not stupid, okay? So the router will always keep track on the interface activity. If this interface is actually down, kalau interface ini memang sudah down punya kan, even that you already configure the IP address, it will never install into your routing table. Dia tak ada tujuannya. Okay, sebab itu IP, itu route sudah hilang. Kalau itu port sudah rosak. Okay, the routing table only show the valid route only. Okay, that's something that you might need to know. Okay, maybe we can do one of the experiment with using the ENSP. Okay, I will go to show you this direct route. How does it actually look like? Okay, so first I'll go to start a new one. Yeah, I take out the router. Okay, with 3 router here. Okay, we can do this one together. 3 router. Okay, then just using the auto. Okay, connect all the router. Okay, this is the network address. Okay, I hope all of you can able to follow me doing this lab together. Okay, I'll show my template. Okay, so you can try to settle this one first. This is my topology and configuration template. So you try to complete this one. So later I will base on this and doing the explanation. Okay, so hope everyone can manage to do this one. So then we can using the display command to check the face. So after I do with the command display IP interface brief. Saya gunakan shortcut ni. Okay, display IP interface brief. Then you boleh nampak that our router got many interface. Okay, tapi semua pun tahu lah because I'm never using that interface. So this is actually normal. So now you just look at your interface here. This is my router dual. Okay, R2. R2, my interface Ethernet port 000. This is 10112. Physical out, protocol out. Okay, physical ialah saya punya interface ini lah, saya sudah connected. Protocol termasuk ialah saya ada configure IP address. Alright, so kalau dua-dua ini pun up kan, that's mean you tak ada problem sekarang. Okay, port number 1, Ethernet port 1 kan, 10.222. Okay, physical dan protocol pun up. Okay, so you have to make sure that your IP address and your physical protocol here is show you the up status. Okay, so I akan gunakan display IP routing table dan chat. When I do display IP routing table, this is what I got. So you boleh nampakkan sebenarnya saya ada banyak IP sini. So ia automatic generate. Ini semua ialah network yang tak sama. Okay, 10.1.1 kan you boleh nampak saya ada dua. Satu ialah saya punya network address dan satu lagi ialah saya punya IP. Okay, so macam tu punya. When you configure one IP address, it will automatically generate the network address and your IP address. Okay, so this is how they actually show you in the routing table. Okay, protocol sana kan, dia tunjuk semua direct. Okay, it's all direct. Okay, tak ada preference, tak ada cost, flex sama di next hop kan, tengok keadaan lah. Kalau ini 10.1.1.0 kan, dia punya next hop ialah 10.1.1.2 sebab saya configure di interface ini. So that's why the next one is pointing to myself. Okay, dan lepas tu sini dia cakap 10.1.1.2. Kalau nak pergi ke 10.1.1.2 kan, macam mana pergi? Ini yang saya sendiri punya IP kan. Then di sini next one dia akan guna 127.0.0.1. Ini maksudnya ialah this is my IP. Okay, 127 is the loopback, is myself. Okay, so first ialah network address, second is the IP. I punya IP. So ini pun sama lah. This is a network address followed by my IP. Yang last sekali sini 127 kan. ini memang auto generate punya. Okay, no need to worry. So this is just a loopback. Okay, you boleh dapat ini adalah ini punya loopback. Okay, interface loopback. So you can use a router. Tengok sebab you sudah ada itu name address. You punya R2 sudah ada ini dan ini. Okay, dua-dua pun ada. So when you already has two IP address, that's mean what? Your R2 boleh ping ke R1 punya network dan juga R3 punya network. Okay, so you can actually try use your R2 dekat sini kan R2 cuba ping 10 111 ya nampak boleh kan, and then you try to ping 10 223 yeah, it's also working. Okay, so if you can get this result, mean yeah, your router have issue, but of course it's only for router. Okay, so this is all about the direct route. Okay, yang tadi tunjuk di dalam slide ni. Okay, ada satu lagi saya tunjuk. Okay, di R2 sini kan. Okay, saya ada interface E000 dan E001. Where IP routing table. Routing table. So I saw all my direct route, including my IP 1011 and 1022. Dua-dua berada. Tapi kalau sekarang I masuk ke itu interface Ethernet 000 sini, kalau saya masuk sini dan apa saya buat, I try to shut it down. Okay, tengok kalau shut down kan dia cakap okay sekarang sudah down dan line protocol IP on the interface sekarang pun down. When you do display IP interface merge, okay, you boleh nampak ini. Itu physical dan protocol dua-dua pun down. Sebab kalau you punya interface shut down, you boleh nampak ada itu simbol di hadapan sini. Sebab ini maksud ialah administrative shutdown. Okay, shutdown manually by ourselves. Okay, kita shutdown bukan device itself. Then down. So kalau physical ini sudah down, apa akan berlaku to our routing table? Okay, let me show you. 10.220 yang tinggal. 10.110 dan tak ada lagi. It will actually gone. The reason because the routing table will only store and keep the active route. Kalau itu route dia tak boleh sampai lagi kan, atau ia punya path itu interface kan sudah ada problem, it's already faulty. Then the router will not going to put this one into the routing table. Okay, because anyway they cannot forward anymore. Okay, sekarang buka balik undo shutdown. This one is only for testing. Okay, you just help me to bring it back. Use undo shutdown. After you already disable the shutdown, display IP routing table again. You notice, yes, it come back. Okay, yeah, again, by when you already recover back the link here. Okay, so if you guys have no problem for this, okay, now I'll process to the next one. The direct, we go to this optimal route selections. Okay, examining the IP routing table. Okay, you have to understand all the attribute right here. Destination mask, the protocol. This is the route preference, the cost. Okay, or some people will like to call this is a metric. Okay, flag. Okay, then the next hop. The last one will be your outbound interface. It's a very long message. So they just want to telling you that what is the meaning for each of the attribute. Okay, I just can show here. Okay, I just explain from here. The destination ialah kita punya route. To send the packet to the destination, and the router is always look for this destination first. Okay, and I did mention earlier on, the router is actually very okay. So the router forward the packet, they know where is the destination. At the very beginning, if the router have no such route, can send to the destination, right? The router will never help you to send. It will just cut the packet. Okay, so here the importance to the router. Used to understand that currently the route is actually learned by what protocol? This is actually my direct route. Okay, I mean it's belong to me. Okay, direct route. Or maybe this route is actually using the static. Okay, we actually manually configure the route for the router know how to go to the destination. Okay, so this is called the static. Okay, or maybe they learn automatic. Okay, it's called dynamic. So the dynamic protocol got so many. Okay, that one I'll also introduce later on. Okay, then after the protocol, here is the preference. So this preference will be used to compare if you have running the multiple dynamic protocol. In one network, you might not only just running one routing protocol, you are running the multiple one. So in this case, how to know which protocol is more preferable? Okay, the high priority. So that's why protocol yang priority yang paling rendah sekali kan, ia akan menang. Okay, so example here, static. The preference is 60. The direct is 0. So in this case, the direct is still is the high priority one. The cost. So if you got using those dynamic routing protocol, and then they'll show the cost right here. When using a static or the direct, they won't show you any cost because those kind of the manual configure the route, they don't carry any parameter. Okay, so that's why static and direct have no cost. Only will show if you are using the dynamic. Okay, flag. Next hop. Just to correct that, if I want to go to this 2.2.2.2, what is the next hop? Okay, so the rest one also the same. So they show the next hop and also the outbound interface. And the next here, the route preference. The basic concept, when a router obtains route to the same destination subnet from different routing protocol, this route have the same destination network and the subnet mask. The router compare the preference of this route and prefer the route with the lowest preference. So sekarang router sudah dapat itu packet yang baru. Okay, so ia akan pergi tengok destination dan mask dulu. Okay, so kalau difference, you actually install in the IP routing table. If let's say the same, then they'll go for checking the preference. Who have the highest preference value, right, will be installed into the routing table. Okay, satu router kan, dia dah Play Store terlalu banyak duplicate punya route di dalam routing table. Okay, so normally right, kalau ada dua program sudah enable atau tiga, dia hanya pilihkan preference yang paling kecil sekali. Okay, now this is the comparison process. Router A discover two routes to 10.0.0.0. The prefix here is 30. 10.0.0.0. Oh, it's on the right side here. This one. One is an OSPF route and other is the static route. In this case, the router A compare the preference of the two routes and select the route with the lowest preference value. So router A, they say the router A discover two routes. Kalau nak pergi ke 10.0.0.3, I can actually using here to forward. Or I can using here. Okay, either one way also can reach the destination. So in this case kan, you boleh dapat di bawah router A, this is router A routing table. Okay, they have a same destination, same subnet mask, but the protocol is different. Preference for the static is 60, OSPF is 10. So if they actually didn't realize that the preference here can modify, okay, then let's see what is this. Router A, right now they receive, I can using static or the OSPF. The static will be go by this way. Let me check, 3112 here. Ini gunakan static. And for OSPF, 2112 here. So if these two also can guide the traffic forward to the destination, dua-dua boleh sampai dia. So then how the router making the decisions? So sekarang kan dia akan pergi compare mereka punya preference. Who actually have the smallest preference value and who will win? So this time the one is preference. Sekarang dia cakap, the router will compare the preference if they are using the different routing protocol. Tapi sekarang kan dia cakap, dia nak pergi ke tempat yang sama punya protocol dan cost. So only the cost is different lah. Okay, in this case, the router A will go to compare the metric of two routers. The two routers have different metric. The OSPF route with the next hop being 30.1.1.2 has a lower metric with the cost 10 here. So it is installed in the IP routing table. Okay, you boleh nampak the other cost dekat sini. So setiap path sini ada cost 10. So then for router A nak pergi ke router sini kan, so dia boleh pilih sini direct because the cost is only 10. And this is the common default value. So how we get default value tak sama dengan yang lain punya vendor. So just to let you know that the direct is always 0, static is 60, OSPF internal is 10. The OSPF external then is 150. Okay, 150. When a router discovers multiple routes to the same destination, the network through the same routing protocol, then it will select the optimal route based on the metric of this route. The metric of the route indicates the cost of reaching the destination address of the route. The common metric including the hop count, bandwidth, delay, cost, load, and reliability. Okay, so you can see the process here. Route to send down here. Look for the destination mask. It's difference to install the IP routing table. If it's not the first time. Okay, the preference. The last is wall. And here, the next content is the route-based forwarding. The first, the router receives an IP packet. It compares the destination IP address of the packet with all routing entry in the local routing table. Bit by bit until the longest match entry is found. This is longest match mechanism. Mana satu yang paling dekat ke itu destination, then dia akan gunakan itu route. Yang tinggal punya route, semua dia pun boleh simpan. Okay. So the longest match. So dia akan pergi tengok. Which one have the longest match? Destination, sekarang dia cakap, okay, destination IP, I want to go 172.16.2.1. So dia ada 3 route entries ini, ada 3. Okay, mereka akan pergi cari kan yang paling banyak match punya. So hadapan sini kan tak perlu pergi check lagi because it's the same. What they want to compare is the holes here. So you can see that right here. You got 6 bit. It's the same. And then right here, 8. A bit plus 6 bit. So how many? So it's 22. Yeah, correct. It's 22. So then after you check, which one have the longest match? This. So entry 1, 2, and this. Mismatch. Apa dia cakap mismatch? Oh, sebab kalau saya pergi buat itu matching kan, sampai sini sudah tak sama. So that's why dia cakap mismatch. Tapi untuk yang kedua punya kan, mereka punya match sebenarnya boleh sampai sini. Sampai this level. Satu sini. Okay, ibu nampak, sini pun sama juga. So this is the reason why this is more match. Okay, 172.16.2.0. So when this is the longest measure, ia akan pilihkan C punya jawapan. Default preference is the same with the administrative distance. Default preference. Default preference. I can't really get what you mean. The administrative distance.
Okay, sure. If I study in school, there's a administrative distance in OSPF, RIF, and in Huawei, you said that there is a default preference. Is it the same, Mister? In Cisco, there's a administrative distance is related with protocol, OSPF, RIF, etc. Like that. Is that the same?
Yeah, it's the same. It's the same. Don't worry.
Same, yeah.
Correct. That one will be the.
Sure.
That one is the algorithm method. How they actually doing the calculations. Okay, because currently, right, the Huawei this slide they just introduce the default. If you know that mereka preference plus mana satu perhatian lagi tinggi. So if I go to show you all for Huawei kan, Cisco memang lain kan. So first, yang paling high priority is called direct. Okay, followed by OSPF, ISIS. Apa lagi ya? Let me think. Oh, static, RIP, OSE. O so small. ASE. Okay, I think it's this one. So then for the cost value one, sorry, we're going to cost value preference. Sebentar. Okay, direct kosong. OSPF 10. Ini 15. Static 60. IP 100. Ini 150. Okay, so this is for the Huawei one. Tapi untuk Cisco yang lain tak sama. So for the Huawei here, the direct is the highest priority. Okay, dari bawah pergi ke atas. Okay. So the highest priority is direct. Sebab ia punya preference kan sentiasa ialah kosong. Okay, so no one can actually beat this protocol called direct. Dan seterusnya kan, second yang paling tinggi punya priority ialah OSPF. Sebab OSPF punya preference 10. Okay, then seterusnya dia follow ISIS. Di Cisco kan, Cisco gantikan ISIS dengan EIGRP. Okay, that one is for the Cisco lah. So Huawei here is actually using the ISIS more. So ISIS here is 15. The static 60, RP 100, OSE, ONSA. Ini ialah OSPF punya extension. Okay, OSPF punya extension area. So that's why ini kan ia punya cost sangat rendah punya. I mean the preference. Okay, 150 low priority, and the last BGP. BGP is 255. Okay, so this is good for you to remember. What I mentioned, this is the default preference. Okay, default mean apa? Kita still boleh modify kan. Okay, so ini ialah default punya original punya preference value. So if you feel that this preference tak boleh match dengan yang lain punya vendor, so kalau saya nak changekan ia punya preference boleh tak? Boleh, tak ada masalah. Okay, you boleh ubahkan dia punya preference. Okay, hope you guys can actually remember this. Okay, so for the IP routing faulting yang paling pertama mereka akan tengok, okay, jangan worry about ini bit dengan sini lah. Mungkin you akan nampak sangat confused kan. So you just check on this. Okay, ini ya tempat yang saya nak pergi punya. This is my destination. Okay, my destination. Dan I punya routing table, I ada 3 route sini. Saya ada 3. Mana satu kan match yang paling banyak. Okay, kalau saya gunakan entry yang pertama, ia match sampai sini saja. 2 ini match saja. Okay, nampak? Sini dia sebenarnya lah /24 kan? /24. So it try to match until here. Tapi kan ini mana match? Okay, ini sebenarnya tak match. Sebab I punya ialah .2.1. Mana betul tak sama kan? The next one. Sini kan 255, 255, 255. So mean I have to match until the third one. Ketiga. Ini ada 3 octet yang match. Okay, yang last ini ya 25525. 2 sajalah, 2 octet. Yang hadapan. Ini pun match juga. Okay, ini pun match. Tapi kan after dia compare 2 sama dengan 3 kan, mereka akan berada, hey, itu IP kedua, dia ada 3 octet, lagi banyak match. So, which one is the more match? Then will be win. Okay, so sekarang router kan, dia akan pilih ini. And this is called longest match. Longest match. So this is the highest priority one. So example of the longest match, there are 2 routes to the 192.168.2.2 in the IP routing table of router A. Sini ya, router A. One has 16 bit, satu ialah 16 bit, dan satu ialah 24. Okay, ini you boleh forget lah, sebab sekarang dia cakap, I nak pergi ke sini. Dot dua. According to the longest match, yang paling match punya kan, dia rasa ini yang paling panjang punya. Sebab kalau dia pilih atas ini kan, dia hanya berapa match saja. Saya pergi 192, 198.2.2. Ini kan dia match hadapan 2. Tapi yang bawah sini dia ada 3. 1, 2, 3 octet. So this one is actually called longest match. So the router will choose this one. Okay, dia takkan pilih yang pertama punya. Okay, another longest match example. According to the longest match rule, all the route to this one in the IP routing match the destination. So it will using that. Ini sangat senang. Sebab dia cakap, saya nak pergi ke sini. 3.2. Kalau sekarang, I want to go here. So when I get this one, 16. 16. So mean it will match the first 2 octet. Yang depannya. Okay, nampak okay, boleh. Dan lepas tu kedua ini kan 24. So that means you will need to check on here. Tapi kan, mana sama. This is dot 3 and this is dot 2. So this is actually wrong. Okay, I'm not going to check with this. Then and this one, /24, dia akan check sampai octet ke-3. So 192.168.3, hey, it's the same. And after I compare the 16 versus the 24, so ini lagi panjang. So you will choose this. In another word, kita hanya yang mana lagi besar. Ya, kan? Okay. So it's called longest match. Okay, then this is the route-based forwarding process. Okay, so the router one, dia dapat paket daripada PC 1010. Dia cakap, saya nak pergi ke 192, boleh tolong saya hantar tak? Itu paket hantar ke router 1. Sorry ya, let me go back. Okay. Ingat, dia akan hantar ke router 1. Since you are my gateway, I will send to you. Router 1 sini akan pergi cari. You nak pergi ke 192, tapi dia tak ada cakap 92. Ayah, I think it's some of the mistake here. Ini bukan 192. Sebenarnya, ya, dia nak pergi ke 40.0.1. Mungkin ini ialah 4 lah. Okay. Okay, so this is the destination they want to go. Okay, this is some of the slight error. So yeah, just try to correct it. Okay. Sekarang dia cakap, I want to go there. PC 1, dia cakap, I nak send the data pergi ke itu IP. So hantar ke router 1 kan. 1 pergi tengok. Antara semua table sini kan. I jumpa sini. Okay, I need to send your packet out from my port 0. So I will send you out to here using this interface. Okay, so then you bring the next up 20.0.1.2 dekat sini. So this is your outbound. Okay, outbound sini. Ini adalah next hop. Okay, outbound and the next hop. So perlu hantar ke router 2. Router 2 sekarang dapat packet kan, you check sekali lagi. I down. Okay, so I must using my G01 here. Dan pergi cari 33012 here and send. So this is how they actually check on the route table. So ini pun sama. Port 01 hantar ke 4011 sini. So the route-based forwarding process. Setiap router pun akan pergi check route table punya. Okay, when they want to forward it to the destination. Okay, so we will just temporarily pause right here. The next content will be the static routing. Okay, so after the break, we come back. I will show you the static route in the Huawei. Okay, we just temporarily pause here first. I set the time, 20 minutes. Yeah, it's good. Okay. Yeah, so we come back after the break.
Okay, thank you, Chef.
This is the world, always moving, always changing. And nowhere is that more true than in technology.
Assalamualaikum warahmatullahi wabarakatuh. Waalaikumsalam warahmatullahi wabarakatuh.
Okay, so we'll back here and continue to the next one. So previous one I already introduced the direct route. Okay, and I believe that you also understand the longest match, preference, and also the cost. Okay, the metric. Then next is about the static. Okay, static ini kan kita perlu manually configured. So static route is manually configured by the network administrator, has low system requirement and apply to simple, stable and small network. So static ini sebenarnya ialah manually configured punya route. Okay, kita perlu fahamkan kalau saya nak pergi ke sesuatu punya destination, where is the next hop? Where is my outbound interface? So cara ini kan sangat sesuai untuk yang small network dan those network bukan sangat complicated punya. Okay, the disadvantage of the static route is that they cannot automatically adapt to network topology change, so require manual interventions. So ia punya problem sekarang ialah macam tu. Kalau kita gunakan static kan, okay, semua itu route yang kita configure punya, dia takkan automatic performkan reroute atau selectkan yang kalau kita punya primary path sudah ada masalah. Okay, so this is the main of the problem right here. So the static can't able to discover the network failure problem. So that's why they tell you it's only suitable for small network. So router A need to forward the packet with the destination address 2110 A 2110. Dia nak pergi ke sini. Di tempat sini kan, this is called the direct. Okay, kita punya router A kan, dia memang ada ini. Okay, sebab ini ya direct interface connected. Okay, ia direct punya. Tapi kalau ia nak pergi ke 20 punya subnet kan, it will actually need the static route to help. Okay, so we help the router A build the static route. After you build it, you have to mention where is the next hop. You perlu pergi cari siapa. So which is router B sini. Ini adalah router B punya IP. So itu packet akan hantar ke router B, B akan forward ke router C. Okay, dengan cara macam tu. So this is the configuration. Maybe I can show in my simulator. So like, okay, now this is my topology. As you can see, the router 1. Ini saya nak ping ke router 2. Sebenarnya tak ada masalah. Okay, sebab I punya router 1 kan, saya sudah ada di route. Itu route bagaimana? It's free IP routing table. You boleh tengok. Mengapa router 1 boleh ping ke router 2? Sebab ia ada itu direct route. 10.112 dia di dalam itu network 10.110/24 di sini. Okay, so 10.112 is actually under this network address. So that's why the router 1 boleh ping. Tapi kalau saya cakap, bolehkah router 1 ping ke router 3? Is it possible? They can ping or not? So router 1 when they want to ping to the router 3, sebenarnya tak boleh. Mengapa tak boleh? Sebab dia punya route sini kan pun tak ada tunjuk. They don't have a 10.220 network. Dia langsung tak faham. Mana sini? Di sini saya tak ada masalah sebab this is my direct. So direct, I will always understand how to go. So this is not the issue to the router 1. Tapi pergi ke 10.220 ini kan, dia langsung tak faham ya. Because this is not my direct route. Dia bukan direct connector saya. So we have to help the router 1 to learn. Okay. Router 1 dia perlu belajar ni. itu IP address. Okay, dia perlu belajar itu network sebab dia punya routing table tak ada. So macam mana tolong dia build? Okay, now I will show you. On the router 1, you just type IP route static. Okay, now I want to go 10.220.24. So where is your next hop? Okay, you punya next hop ke mana? So next hop sentiasa ialah you punya gateway. Okay, sekarang router 2 ialah gateway for router 1. So kalau router 1 nak pergi ke router 3, bukan. Kalau router 1 nak pergi ke sini punya subnet, okay, then dia perlu cari sini punya IP. Okay, sebab sana ialah gateway. So this is the destination. Okay. Tapi di sini kan, this is your kita panggil next hop. Okay, so this is called the next hop. So when you actually type the static route, always remember the first is the destination. Okay, must. Then the last kali kan, dia akan tanya where is the next hop. Okay, next hop. So next hop ialah 10.1.1.2. Just like this. Okay, we do it on the router 1. Okay, we try to do this one together. Okay, saya sudah buat ini ya. Display IP routing table. So sekarang you display kan, you boleh nampak ini. Ini adalah route configure daripada kita. Okay, we are actually configure ourselves. We going to inform the router 1, hey router 1, kalau you nak pergi ke 10.2.2.0, okay, ini create daripada saya. So we name it as a static. Nampak tak itu preference? Tadi saya ada tunjukkan preference untuk static ialah 60. 60. So kalau you nak pergi ke 10.2.2.0, you punya next hop, you perlu pergi cari 10.1.1.2. Dia akan tolong. Okay, the router 2 will help. Okay, you need to look for router 2. And where is the outbound interface? Ethernet 000 here. Even I never configure the outbound interface, don't worry. Sebab sangat senang ni. Ini IP 10.1.1.2 kan. Dia di mana? Dia di sini. 10.1.1.0 punya network. Dan itu network dia di dalam interface 000. So that's why sini dia automatic akan register. Dia sudah faham ni. Okay, it will automatic appear. But doesn't mean sekarang you punya router 1 atau you route kan, you sudah boleh ping. Okay, it's actually not mean that after you already have this route, you can ping. No, it's not like that. Okay, sekarang let me try. When I try to ping 10, 2, 2, 3. Okay, you guys pun boleh cuba. Kan? Boleh, okay. Walaupun you sudah ada itu route kan, tapi router 1 still tak boleh ping ke router 3. Do you know what is